This is for U12 Specialist. It comes out of the 2019 Application Task Tech Allowed question number 2, which is a vectors question. So we have this parallelogram where A has been nominated to be in this direction, A to B, and B is B to C. So B is opposite to what we expect. DB internal ratio of 2 to 1. If that's 2 and that's 1, therefore we have thirds, and D to X is 2/3 of D to B, and that's a midpoint. Okay, so in A, B, and C, I'll have things in terms of A and B. Then I'm told what A and B are, so I can use the actual vectors. Okay, so for dx, D to X will be 2/3 D to B. D to B is minus A plus B, so this is an expression for dx. And you're asked to find Cx. Well, C to X is C to D plus D to X. So C to D is minus A plus this here, gives me this expression for C to X. And if I'm going to show that they are collinear, that is M, X and C are collinear, I've got an expression for Mx. I have an expression for Cx. And you can now see that they're parallel to each other because Mx can be expressed as Kcx, where it's going to be -1/2 Cx. Therefore, Mx equals -1/2 times Cx. -1/2 gives me 1/6, yep. Therefore, they're collinear. Okay, so that's A, B, and C done. To do D, I need the area of this triangle. The formulas that I have for the area of triangles is 1/2 base times height, which in this case is no good because I don't know the height. I can do 1/2 AB sine of C. So if I knew this length, and I knew this length, and I can use the dot product to find theta, I could then use this because it's 1/2 times 2 sides times the sine of the included angle. Or you can use Heron's formula. If I knew the side lengths of all three, I could use Heron's formula. Okay, so I'm going to use this one. So, MB, I know from up here, it's MB is 1/2 times A. Therefore, this is going to be MB. And using my calculator, the magnitude of MB is √29/2. So the magnitude of MB is √29/2. And MX, I'm going to use MX because MX was already given to me here in the previous question. And MX, if I substitute 1/6 A plus 1/3 B, gives me this expression for MX. So its magnitude is √41/6. So I've got √41/6. The dot product of these two will be 1/6 times this, 17/12, sorry. So I can now use that information to find the angle theta. Because if I've got MB dot MX, it's the magnitude of MB, magnitude of MX, times the cos of the angle. Therefore, the cos of the angle will be, if I move this down to there, 17/12 over this, and on a calculator that gives me 60.46 degrees. So now I'm ready to use the area formula where I'll have 1/2 AB sine of C, and on a calculator that gives me 5/4 square units.